We all use GPS pretty much every single day, right? To find a new restaurant, check the traffic. We don't even think about it. But here's the thing the GPS in your phone is, well, not that accurate. It's nowhere near precise enough to build the world around us. So today, let's pull back the curtain on the other GPS, the hidden, hyper precise system that makes all of modern construction and engineering even possible.
Okay, so to really get how this super accurate system works, we first need a quick refresher on the GPS we're all familiar with. I mean, we use it all the time, but it's kind of easy to forget what's actually going on behind the scenes.
So, at its very core, the Global Positioning System, or GPS, is pretty much what it sounds like. It's this amazing network of satellites whizzing around the Earth, and they're all beaming down signals. Your phone just has to listen to a few of those signals to figure out almost exactly where you are on the planet.
And the whole system is really made of three main parts. You've got the space segment, that's the constellation of satellites orbiting way, way up there. Then there's the control segment, which is a bunch of ground stations that are constantly monitoring those satellites, making sure their clocks and positions are perfect. And finally, you've got the user segment. And yep, that's us. Anyone with a receiver in their phone, their car, you name it.
But here's where it gets really interesting. For as awesome as it is, the everyday GPS we all use has a pretty big weakness. A limitation that creates a huge problem for anyone trying to build, well, anything with real precision.
I mean, just think about it for a second. When you're putting together a massive bridge or pouring the foundation for a skyscraper that's going to scrape the clouds, being off by a few feet isn't just a mistake, it's a catastrophe. You need accuracy that's down to the centimeter, sometimes even less. And now, look at this. This is the heart of the problem. Your phone's GPS is only accurate to within about 3 to 10 meters. That's a pretty big area. But an engineering survey, they need accuracy of just 1 to 2 centimeters. We're talking about a system that has to be literally hundreds of times more precise. It's a whole different ballgame. So here's a simple way to think about it. The GPS that gets you to the front door of the coffee shop is totally, completely useless for actually building that coffee shop. You couldn't pour the foundation or put up the walls with it. For that, you need a whole different strategy. And that brings us to the really clever solution. It's a technique that takes this kind of imprecise system and turns it into a tool with surgical accuracy. And it's all about a story of two receivers working together as a team. This amazing solution is called differential GPS, or DGPS, and the idea behind it is just brilliant because it's so simple. Instead of just one receiver trying to figure everything out on its own, you use a second one, basically to check its homework and correct all the little errors in real time. So let's meet this dynamic duo. First, you have the base station. This is a GPS receiver that's locked down in one spot, usually on a tripod, over a point with an exact, perfectly known coordinate. Think of it as the anchor, the source of truth. Then you have the rover. That's the mobile unit, the one the surveyor carries around the job site to measure all the new, unknown points. Okay, so here's where the magic happens. The base station is sitting there listening to the same satellite signals as the rover. It calculates its position. But, and this is the key, it already knows its real position down to the millimeter. So it can instantly see the error. It'll say, hey, the satellites are telling me I'm 5 centimeters over here, but I know I'm actually right here. That difference is the error. The base then packages up that error into a little correction message and beams it over to the rover. The rover gets the message, applies that same correction to its own measurement, and bam, just like that, its position is corrected with centimeter-level accuracy. Now, this ability to correct errors on the fly, instantly, has completely changed the game for surveyors. It led to a method that gives engineers and construction crews that ultra-precise data they need right there in the field with no waiting around. And that method is called real-time kinematic, or RTK. This is the absolute standard in the industry today because it gives you that incredible precision and it does it instantly. The real-time part is what makes it so powerful. You get the correct answer the second you take the measurement.
And the actual gear a surveyor uses for this is pretty cool. You've got the receiver and antenna to listen to the satellites, a data controller, which is basically a rugged handheld computer to run the software, a little radio to get those corrections from the base station, and of course, a sturdy tripod for the base and a lightweight pole for the rover.
So just how accurate are we talking here? It's honestly mind-blowing. Using RTK, a surveyor can get horizontal accuracy, that's side to side, of about plus or minus 1 centimeter. And for vertical, so up and down, it's about plus or minus 2 centimeters. That is just an unbelievable level of precision.
So when you have that kind of power in your hands, DGPS isn't just some niche tool for surveyors anymore. It becomes a foundational technology. It's what enables us to build the incredibly complex world that we all live in today.
And this table really just puts that leap into perspective. I mean, look at it. Compared to older methods like a tape measure, it's not even a fair fight. DGPS RTK is orders of magnitude more accurate, and it rivals other high-tech tools while being way more flexible and letting you cover huge areas really, really quickly. Let's just pause on this number one more time. Plus or minus 1 centiliter. That's about the width of your pinky nail. That is the entire margin of error they have for positioning a stake that's going to guide the construction of a highway or a pipeline or a massive building. It's all thanks to this incredible system. And the applications? Oh, they're everywhere you look. Creating those super detailed topographic maps, laying out the perfect smooth curve of a new road, figuring out exactly how much dirt needs to be moved for a foundation, even mapping out all the critical pipes and cables for a city's digital map, all of this relies on DGPS. So the next time you pull out your phone to use GPS, maybe just take a second and remember this. While you're using one version of it to get around, there's another, much more powerful version working silently in the background, literally building our world with a precision that's hard to even wrap your head around. It really makes you wonder, right? What other invisible technologies like this are out there, quietly shaping the very ground beneath our feet?